Programmers Live, good evening. Hope whoever is watching right now, you are well. Now, last time we had quite a lot to do. I left with a number of questions, and I'm sure before you watching this episode, you've already done all those questions and done a number of research in the different sections we have covered since the first episode of C++. We are here yet again, but I will begin this session with a number of questions. As you can see them, they are all calling for programming solutions. Remember, we said programming is about giving solutions. Programming is about solving problems. That is why, as we are learning, we keep having small problems, and we keep learning how to find solutions to these small problems. So the more problems we solve, the more experience we get, and the more we learn the language. So this means that someone cannot learn how to program unless if they are programming. You cannot learn how to solve problems unless if you've been solving problems. By the time someone begins solving a big problem, then they have solved quite a number of small problems earlier, or problems of varying magnitude. So you have a question up here. They're just scenario questions. I wanted to share them with you. Of course, along the way we are going to be doing some, and some will be left to you who is watching right now. The gravitational field of the moon is approximately 17% of that on the Earth. Write a program that calculates the weight of a man on the moon by a given weight on Earth. Wow, it's an interesting idea, and I'm very sure it's very simple to handle. Another one is write a console application. Of course, all along we've been developing console applications that prints your first and last name on the console. This is the easiest, I think. Then calculating the area of a trapezoid. Given the sides AB and height, which is h. So if you don't know how a trapezoid looks like, please endeavor to, but at least you already know. The program expects 2 inputs before it gives you 3 inputs before it gives you an output. Another one is about entering your age, then it prints age after 10 years. Okay, think about that. And quite a number of other questions down here. So we are going to be revisiting this section as much as we can, just to pick out some questions to do. Definitely we shall, but today for this session I'm adding from where we ended previously. Is this where we ended? Nope, I doubt. Okay, this is the slide where we ended, the tab where we ended. Now today I want us to talk about methods, or what we call functions. Now I began this session by talking about problem solving, reminding you to solve a certain task or to solve a problem, especially those problems that are complex. We can do that very well in programming if if we implement the concept of divide and conquer. I know people have been hearing about this. It's a Roman ideology of problem solving. You divide, then you conquer. What does it mean? It means that if I have a big problem, if I have a complex problem, it is better if I solve it the easier way. How? Let the big problem be split into smaller problems. Hope you're listening. Let the big problem be split into smaller problems. Now you begin solving or finding solutions to each small problem, but at the end of the day you realize that you're finding an entire solution to this big problem. Okay, so we are borrowing this from the concept of divide and conquer. So using the same idea, when we are writing applications, when we are developing software, when we are developing applications, remember we said we are aiming at solving a problem. Okay, so what shall we do? We shall split the problem into smaller tasks so that we look at each task as an independent task in its small form, but at the end of the day we are completing a bigger task. Now, in the world of programming, in the world of providing solutions, this can be done through using methods. Methods can also be called functions, and they can also be called subroutines. So don't be confused. I'm saying methods can also be called functions, they can also be called subroutines. Now the question will be, what is a method, or what is a function, or what is a subroutine? Now, a method is a basic part of a program. Okay, it's a basic part of a program, or like I told you, it can be called a code fragment or a code snippet. Okay, that is written to perform a specific task when called. That is what we call a method. Now, methods consist of what we call the program's logic. They consist of what we call the program's logic. Up there I've said it's a code fragment or a code snippet that is written to perform a specific task when called. Now calling, I'll bring in that later, but at least you can pick or grasp the first part of it, of performing a specific task. Then I'm saying they consist of what we call the program's logic. Okay, now it means that they will allow us break the program into small blocks. Okay, functions or methods allow us to break the program into small blocks with a name, with an aim to build bigger programs. Divide and conquer is the one that I'm trying to explain here. Now someone will ask, why methods? Why do we use methods? Why are we talking about them? Of course in the first layman understanding, one of the reasons as to why we are talking about methods is because they are part of the language, and the target is to learn the language. So since they are part of the language, then it is a task of a program or anyone that is encountering the language to learn about methods. But being official, why do we need methods? Methods help in what we call code reuse. Methods help in what we call code reuse. Okay, now this helps a programmer to avoid repetition of the same lines of code in a program. What does code reuse mean? Code reuse means that you can have a single method and you can call it so many times, or you can use it so many times. So you write once and use many. Write once, use many. Write once, use many. So that is what we call reusability of code. So with code reusability, it means you are doing what we call avoiding duplication of code. You realize that someone has about 100 lines of code, but most of them are already duplicated. Okay, then 2, we need methods to simplify, like I've already stated it up there in my explanation, to simplify problem solving. Okay, more so we have scenarios of complex problems. Scenarios of complex problems that require recursive solutions. You shall know what recursive means, but one of the reasons that we've already mentioned is that they simplify problem solving. Okay, so we have code reuse, we have simplicity. Then another thing is they provide better structuring of the program, which gives better maintenance. Okay, which gives better maintenance of the program. You know, the moment you are a programmer, whatever you write in the program, that is a cross that you need to carry for the rest of your life, for as long as you're still managing that program. So it means that the moment you don't have better structures in the program, then it is hell for you to manage and maintain such a program. So for someone to have the ability to have a better structuring in the program code, then it can be assisted through use of methods or functions, or what we call subroutines. So I think now at least the programmer knows why they need to learn how to use functions. Okay, now we have what we call what are the operations on methods. So if I'm going to use a method, then what do I really go through? One, we have what we call declaration of the method. You shall know what it means. It means you're introducing it to to the program, and you're letting the compiler know that I really need to use this method. So declaration, okay, it's the same as method registration. You're creating awareness, I'm going to use this method. Okay, so that is one of the processes or the operations that you go through. Then we have what we call definition. Definition is the same as identifying the task, identifying the task of the method. What is the method going to do? Fine, you've declared, you've stated it, you've introduced it to the program, the compiler knows about it, but again, what is it going to do? So that operation is called a method definition. Then lastly, and that is the target, we have what we call a method call, or sometimes it's called a method invocation. That is why in my definition, if you recall, it's written to perform a specific task when called. So calling or invocation is the last of the operations when you have already declared and you have already defined what the method is going to do. Are we together? Now let's talk about the syntax. Let's talk about the syntax. Now syntax is, we have what we call a return type, we have what we call an identifier, we have what we call parameters, and we have what we call a body. Wow, hey, that is how a method looks like. So explanation before we enter into having an example. We shall begin with what we call return type. Can be any valid data type. Okay, it can be any valid data type. It can be a void, we talked about it. It can be an integer, a double, a float. So it can be. Okay, so that is what we call. So return type means that if I told that function is to carry out any kind of computation and it has to give a value, then that value should be of a specific data type. That is why we call it a return type. Now identifier, name given the function. Identifier means name given to a function. What does it mean? It means that every function should have an identifier. It should have a name, and this name should follow the rules of variable naming. Someone is going to ask, what are the rules of variable naming? Please go and watch the previous episodes. We really talked about this. Then there is something that is called parameters. Now parameters, these are values passed the function. Parameters, these are values that are passed to a function, and each parameter should have a data type. Guys, whatever I'm saying is not a movie, this is reality. Fine, each session I handle, I call it an episode, but that doesn't define it as a movie. This is reality, guys. Okay, so parameters, these are values that are passed to a function. But I'm going to come back to to parameters again at a later stage. But what I was trying to do is that I was trying to explain to you what we call a function. Now that is how basically a function looks like, but I want to pause at this point where I'm talking about parameters. I'm going to come back. Now functions have types. One, we have what we call, sorry about that, we have what we call user defined functions. Okay, then two, we have what we call pre-defined functions. Ladies and gentlemen, try to keep track of where we started and where we are right now. I'm saying functions have types. We have what we call user-defined types, user-defined functions, and we have what we call predefined functions. Now user-defined, these are created by the programmer to solve a task. So if a programmer writes their own function, then that function is called a UDF, a user-defined function. And these ones are also two types. We have those which are called pure functions. Guys, are we together? Then we have those which are called prototypes. Wow. I'm going to say this again. I started with what a function is, other names of a function, then why do we need functions. I surrounded it here. Then what operations are performed on a function, I talked about them here. Then later I showed you how a function can look like. Then I went again and tried to talk about those different parts of a function, but I ended somewhere where it says parameters, and I said parameters are values that are passed to a function. Okay, now being values that are passed to a function, then I said each parameter should have a data type, but I ended right there. Then I said these functions have types, and among their types we have what we call UDFs and we have PDFs. PDFs means predefined functions. Then I said under user or UDFs we have what we call pure and we have what we call prototypes. Now pure these are declared. I talked about this up there. Declared and defined at the same time. This is what we call pure. Declared and defined. Okay, defined means give a body. Okay, defined means give a body. Then declare means give a return type, comma, give an identifier, comma, give parameters. I'm doing my best to help you understand. These are one of the most interesting topics when it comes to programming. So we are saying in C++ we have two types of functions. user defined and predefined, but under user defined we have pure and we have prototypes. So prototypes, these are declared and defined later in the program. Okay, declaration is what is given, then definition is later. Okay, now predefined, these are part of the language framework, and they are known to the compiler. These ones come with the language. Okay, an example without even wastage of time, there is what we call a main function. I know from the examples that we had, you see there is a function called main and its return type is int. I think it's now making perfect sense. So these are part of the language framework and they are known to the compiler. Another thing that you need to know about them is they are extracted from libraries. They're extracted from libraries. Let me remind you of something. Examples. Last time we had a library called CMath, and from CMath we have functions like sqrt, we have functions like log, we have functions like sine, we have functions like abs, we have functions like poll, we have functions like seal, guys, the list is endless. We have functions like flow. So I should say these are predefined. And where are they got from? They're extracted from libraries. I gave you an example of a library and I gave you a list of functions which can be got from that library. Okay, so of course much will be coming in the future. So predefined and user defined. Okay, now we gave a syntax up here. Okay, now this syntax I'll copy again. This syntax is part of what we call a pure function. This syntax is part of what we call a pure function. Okay, and we can have examples at hand. I can say int product. My function is called product and I have int x. So I can say int result. I have another variable which is called result, and if it is product, let me have two parameters. I can have int y also. So I'll say int result, then it is x times y, then finally I will say return result. Wow, so we are having an example. Now this example needs a proper explanation for someone to pick. The return type of the function is integer. That is what I chose. The name of the function is called product and it has two parameters. Okay, it has two parameters. So I will say list of parameters are x and y. Okay, list of parameters are x and y, and they are both integers. Okay, note a function can have no or one or more parameters. Guys, I don't know if I'm making life more proper. Okay, let me push these ones a little bit further so that we make things perfect. I'm saying this is the syntax of a pure function, because we said a pure function is declared and defined at the same time. So you give it a return type, an identifier, parameters, which I have done here. Then at the same time you give it a body, or you define it, which I did here. Okay, so I can put a comment here and say this is what we call definition inside. Then I said the list of parameters that we have is x and y, but a function can have no or one or more parameters. So if there are more than one, please use the comma operator. We talked about it in the previous time. This was not 1, and let's make this not 2. Okay, if a function, or don't forget the names, a method is performing any computations, then it should have a return statement. Guys, are you marking whatever I'm talking about? I'm not getting these things from heaven, I'm getting them from my head, and they are the rules of the language. Okay, so don't think anything otherwise or outside what we are talking about. For as long as you're thinking within the same scope of the language rules, then you are perfect. So I'm saying if a function or a method is performing any computations, then it should have a return statement. Why should we have a return statement? If you don't command a return, if you don't command a return, shall put a comma there to make English better. If you don't command a return, then the function will never give you the outcome of the computation. I don't know if whatever I'm saying is clear. Guys, I said this is not a movie, this is the reality. So it's a mandate that each time a function is performing a computation, then it requires that you return a value. That is why here I said that after multiplying x and y, please give me the result of the computation. So that is why here I'll say command return so that you get a result. Okay, command a return so that you get a what? You get a result. So that is a must. You need to do that for as long as a function is carrying out a computation. Guys, all together. Now another example. This was example 1, so you can have example 2. Example 2, I'll say void greet me. Then I'll say out hey programmer, how is C++? It's a greeting statement. Now I have another function here, and this function is called greet me, and it is a void function. Remember, I told you void means return nothing. Definitely, the moment I have void here, then I can never have a return statement inside the body of the function. Guys, am I clear? So up there in the previous example here, I gave an int. An int, of course, is a signal that you never know, at the end of it all I might get a result. If you had not realized or noticed that, I have the main function and it is always identified as an int. You see that in the previous for loop example that we had. But each time we are ending a program, we say return 0. I told people in some episode to go and read about the return 0, and I'm very sure you did. But now we are confirming certain ideologies now about functions. So it's an integer right here, and that is why we are able to return. And this return 0 means that the program has executed successfully. That is the true meaning. The program has executed successfully. I think we are together. So that is why we are having a return. But back here, for us here, we did a computation of multiplying x and y, and definitely we need the result after computation. Here it is a void function, meaning in a layman, don't give me anything after whatever you've done. That is why inside I don't have a return statement. Are we there? Don't forget, we are still talking about methods or functions. So a recap in this section: a function definition means that I'm giving a function a purpose. Okay, a function definition means that I'm giving a function a purpose or a task. A function declaration means that I'm introducing the function to the program and I'm letting the compiler know I'm going to use the function. Okay, so those are part of the operations which are performed on functions. Then we went ahead and we said functions are of two types. We have those that are created by the programmer, and we have those that are part of the language, and we said these come from libraries. I even gave you an example of C math, and I showed you a list of functions that come from in there. But when I reached user defined, I told you user defined we can have pure, and at the same time we can have prototypes. I told you pure, you declare, declaration means this, then I said and you define at the same time. Okay, so this means you give the function a task, and I told you the syntax is what we have below here, and we have an example there, and we have another example right here. So once again, please don't forget to subscribe to my YouTube channel, Programmer's Life. Then if you want to reach out to me any questions, any consultations. +256. Okay, I'll write it here this time. +25675182497 okay, or you can reach me out on programmerslife@gmail.com. okay, I sign out.